In the 1940s, radar operators began detecting a mysterious signal. It wasn't coming from an aircraft. It wasn't coming from another radio station. It was coming from the sun. And that presented scientists with a rather interesting problem. Why was the sun making noise? One of the scientists who became fascinated by this question was the Australian physicist Ruby Payne-Scott. She had worked on radar during the Second World War, when unexplained interference was generally something engineers wanted to remove. But this particular interference had an unusual habit. It seemed to follow the sun. Perhaps Payne-Scott and her colleagues realized the equipment was not malfunctioning at all. Perhaps it was detecting something real. This was a rather different way of thinking about astronomy. For centuries, astronomers had learned about the sky primarily from light. Telescopes collected it. Photographic plates recorded it. The universe was something scientists looked at. Radio astronomy suggested that it could also be listened to. Payne-Scott began investigating the bursts of radio energy coming from the sun. They were not all the same. Some appeared suddenly and disappeared within seconds. Others changed in frequency as they developed. By studying these patterns, Payne-Scott and her colleagues helped distinguish different types of solar radio bursts and connect them with activity taking place on the sun. But detecting a signal created another problem. Where exactly was it coming from? Early radio telescopes could not simply produce a detailed photograph of the solar surface. Payne-Scott therefore helped develop remarkably inventive ways of extracting more information from relatively simple equipment. One technique made use of something that hardly looked like part of a telescope at all: the ocean. At an observing station on the Australian coast, radio waves could reach an antenna by two routes. Some traveled directly from the sun. Others reflected from the surface of the sea before reaching the same receiver. When the two signals met, they produced an interference pattern. By studying that pattern as the sun moved across the sky, researchers could estimate where particular radio emissions were originating. The sea had effectively become part of the telescope. These observations revealed a sun very different from the calm yellow object visible in the sky. It was magnetically active and capable of producing enormous eruptions of energy. Radio waves allowed scientists to detect aspects of that activity that visible light alone could not reveal in the same way. Payne-Scott became one of the pioneers of solar radio astronomy. Her career in the field, however, was remarkably short. In 1944, she had secretly married. Australian government employment rules at the time placed severe restrictions on married women holding permanent positions in the public service. When her marriage became known, it affected her employment status. She eventually left radio astronomy in the early 1950s. The science she had helped establish did not. Radio astronomy expanded rapidly. Scientists began using radio telescopes to investigate distant galaxies, pulsars, clouds of gas, and some of the most energetic phenomena in the universe. The sun remained an important radio source too. Today, observing solar radio emissions helps scientists understand solar eruptions and the space weather that can affect satellites, communications, and technology on Earth. And there is something particularly fitting about how this story began. A strange signal appeared in equipment designed for something else. It could easily have been dismissed as noise. Instead, scientists asked where it came from. Ruby Payne-Scott helped find the answer. Sometimes scientific discovery begins with seeing something nobody has seen before, and sometimes it begins by realizing that the noise you are trying to remove is actually the thing worth listening to.